Very good morning, my dear friends and channel viewers. Myself, Dr. M.H. Annaya, and in today's video, we are going to work out the design of a boiler joint. And this particular joint in this chapter, design of riveted joints, is a very important question that is generally asked in the examination question paper. Friends, we have been asked to design the longitudinal and circumferential joint for a boiler, given the diameter of the boiler and also what is the pressure inside the cylinder. So friends, here in the design of a boiler joint, we are required to design two different joints. One is for the longitude along the length of the boiler or the shell, which is called as the longitudinal joint. So we have to design number one, the longitudinal joint along the length of the boiler. Longitudinal joint. The second one is the circumferential joint. Circumferential joint. So this covers both. Sometimes in the examination, they will ask you only design of the longitudinal joint. Sometimes they will ask you both. And most of the times, they will ask you to find or to design the longitudinal joint. Now friends, let's see how to design this longitudinal joint. Friends, here for the question we have been given what is the pressure inside the shell and what is the diameter of the shell. So based on this, we have to start from finding out the thickness of the shell, or that is the steel plate, which is to be bent in the form like this. So we have to find out what should be the thickness of the shell required. That is H is the thickness of the shell, and the inside diameter is di, and that is being given as 2 point, that is by the 2 meter dia. 2 meter dia is the diameter of the shell. Pressure is given to you. So the longitudinal joint is a butt joint. This should be remembered by you, because once you know this, the design procedure for the remaining part is very simple. So the longitudinal joint is a butt joint. Longitudinal joint is a butt joint. This may be double or triple riveted. Double or triple riveted. And here the thickness of the plate or the shell of the boiler is found out from the formula. The thickness of the shell, that is represented by H, is given by the formula P of di divided by 2 eta sigma theta. This is given in the machine design handbook. The formula is to find out the thickness of the shell. Friends, here this PF stands for the pressure inside the shell. That is the pressure that will always be given in the question. The pressure in shell or inside the boiler, that is given to be 2.5 Newton per mm square. Newton per mm square. And di is the inside dia of shell. So inside dia of the shell, that's given to be 2 meter. 2 meter. So 2 into 1000 mm, that is 2000 millimeter, divided by this 2 eta sigma. Sigma theta is also called sigma T, that is the tensile strength of the material of the rivet and also of the plate. So this is given to be 90 Newton per mm square. So we are left with calculation of this eta. What is eta? Eta is the efficiency of the joint. Eta is the efficiency of joint. So if you are able to find out this eta, then we can substitute in the formula and find out what is the thickness of the shell required. Now I will tell you how to find out the efficiency of the joint. Sometimes in the examination paper it may be given, but as a design engineer, you should know how to obtain the efficiency of the joint. Friends, to find out this efficiency, there are two tables given in the machine design handbook in the chapter Riveted joints. And here, based on the diameter of this shell, there is a joint suggested. So here we know this longitudinal joint is a butt joint, and the type of joint, that is the joint double or triple riveted, depends on the diameter of the shell. So here the diameter of the shell is given to be 2000 mm, that is 2 meter, 2000 millimeter. And for this particular diameter, there is a table in the handbook in which diameter range is given, and the type based on the diameter, you are called the diameter is 2000 mm, and here they were giving you what is the joint suggested, that is double or triple riveted. For this diameter, we have the type of joint suggested as triple riveted butt joint. It's a butt joint, so triple riveted butt joint. So you have to first of all find out what is the joint. For this range up to 2000 millimeter, the triple riveted butt joint is suggested. And after knowing the type of this joint, that is triple riveted joint, there is another table which will give the efficiency. So there are two columns like this. One is the type of joint and efficiency range, efficiency, or you say eta. Two values are given. One is the range and other is the maximum value of efficiency. So here friend, if you refer to this table, so for this triple riveted butt joint, the efficiency range is 86 to 88. So that is 84 to 88. So we'll take some value as some 84%. So based on this, we will go ahead and find out what is the thickness of the shell required. So once again, I'll repeat the procedure. Depending on the diameter, refer to the table and find out what is the nature of joint suggested, whether it is double riveted or triple riveted. Based on that, refer to another table wherein you find the efficiency range. And friends, here I am going to select eta is equal to 0.84. That is 84%. Now if you substitute in the formula, you get H is equal to P of pressure is 2.5, di is 2000, pf di divided by 2 times eta is this value, and sigma theta is given to be 90 Newton per mm square. Shear stress, tensile stress, compressive stress. So friends, if you simplify this, you get this value of H as 33.088. 33.088. And friends, after getting this value of H, generally this we make a small allowance for corrosion. So we generally take this as 35, slightly higher value. So allowing for corrosion or making provision for this corrosion, comma, we can take H is equal to 35 millimeter. So slightly higher than whatever you get. So this is the first step in the design of this longitudinal joint, which is a butt joint. Now friends, after finding out this thickness of the shell, we can find out what should be the diameter of the rivet required. Friends, we have H is equal to 35 mm, and this is greater than 8 mm, the standard size. Therefore, you can adopt the diameter of rivet dia of rivet equal to 0.2 times root H. Is a formula given where this D and H are in meter. So 0.2 times root of H is 35 mm divided by 1000 to convert that to meter. And friends, this works out to 37.4 mm. After conversion, it will come to 37.4 millimeter. This is the diameter of the rivet. But friends, as design engineers, we cannot simply take a value, whatever you get here, and we have to adopt what is called standard size of the rivet required. And in the handbook, there is a table in which are given the standard diameter of the rivet and also the diameter of the hole to be drilled in the plate. And friends, we have the next standard size as 39 mm is the diameter of the rivet standard size, and the corresponding hole diameter, the diameter of the hole to be drilled, DH, is 41 mm. So we are able to find out both the diameter of the rivet and also the thickness of the shell required. And now friends, let us move on to finding out the different values. Now we are designing a longitudinal joint, and I told you it is a triple riveted lap joint wherein there will be 3 rows of rivets on each plate, and it is a double cover plate, that is a butt joint with double cover plate having unequal width plates. So here we are designing triple riveted butt joint with double cover plates. The butt joint, so we are using double cover plates of unequal width. This you should remember. Now friends, if you refer to the data handbook, there is a big table in which all types of the riveted joints, like the lap joint, single riveted lap joint, double riveted lap joint, butt joint, single riveted butt joint, double riveted butt joint, and butt joints made with double cover plates of equal width, unequal width, etc. Now for this particular problem, we have selected already triple riveted butt joint. So friends, I will just show only one of the plates we have got. So this is one plate and this is the other plate. So friends, here there will be 3 lines of rivets, one here and 2 on this. So if you refer to the table, if you are able to identify or you be able to locate where this joint is, then all other information are given in the handbook. So analysis of this is very important. So friends, I will write down here R1, row 1, this is row 2 and this is row 3. There are 3 rows. And here is the upper plate and there will be one more plate below that. And here friends, there are 2 cover plates. The first line, if you observe friends, all the rivets in the first row, they undergo single shear. Whereas these 2 rows, R2 and R3, undergo double shear because the same rivet gets sheared at 2 different locations. Double shear, single shear and double shear. And if you take one pitch length friends, this is called the longitudinal pitch. Along one pitch length friends, there will be a half place of one rivet and a single shear, and again here half place of half place half. So here there will be one rivet and single shear, half place of, again half place of. So the number of rivets failing by single shear is taken as 1 half place of, and here this is 1 plus 1, that is I2. That is the first row of rivets fail by single shear and the value of number of rivets I or I1 failing by single shear is 1. Whereas these 2 rows of rivets undergo double shear and the number of rivets failing by double shear is represented by I2, that is half place of 1, half place of 1, it is totally 2. 2 there and 1 here. Now friends, till now we have found out the diameter of the rivet and also the diameter of the hole to be drilled in the shell. Now friends, let us find out what are the other parameters of this longitudinal joint. So next we are going to find out what is called the longitudinal pitch. To find longitudinal pitch, and this is represented by P, small p or whatever it may be, longitudinal pitch. So friends, to find out this longitudinal pitch, we equate F tau to F theta dash. F tau is the strength of the joint in shear, and this is the strength of the plate with hole, that is the perforated. And friends, this F tau is given by the formula I into pi d square by 4 into tau. And this is strength of the plate with hole is given by P minus D into H into sigma T. Friends, all these equations are available in the machine design data handbook under this chapter, riveted joints. Friends, I will tell you about the dimension analysis. F tau is a strength. It should be expressed in Newton. I stands for the total number of rivets. That is here. This is I1 plus twice I2. I will tell you what it is. Twice I2. I stands for I1 plus I2. 2 I have written. I will tell you why it is 2. Pi d square by 4 into tau is equal to P minus D into H into sigma sigma theta. Friends, here I1 I have shown you in the previous step. I1 stands for the number of rivets failing by single shear. So the first row fails by single shear and I1 is equal to 1 I have given. I have put as 1. Place this instead of 2, what happens? It has been found by practice that a rivet failing by double shear is not twice as strong as a rivet failing by single shear. So it will be 1.875 times stronger than a rivet failing by single shear, even if they are having the same diameter. So instead of 2, write on 1.875 times that I2. I2 we have got 2. This is the value of this I1 plus I2 multiplied by pi by 4 d square into tau is equal to P, the longitudinal pitch, into D into H into sigma theta. Friends, here we know the value of D. The shear stress is given to be 60 MPa, 60 for the shear, 90 for the tensile, compression it is 120. So friends, we have got this value. D we know, H is calculated, sigma that is 90. So from this friends, you will be able to find out what is the longitudinal pitch for this giant. So friends, this works out to 147.082. 147.082 millimeter. This is the longitudinal pitch for the bud joint we are designing. Now friends, for practical purposes, to reduce or to prevent leakage of steam in the boiler, the value of P is slightly reduced. It's only an approximation. That is, whatever this fraction part you have got, that can be deleted and you say adapt the longitudinal pitch P is equal to 147 millimeter. So we have got the longitudinal pitch of this. Friends, after calculating the longitudinal pitch, let us see how to find out the transverse pitch. So to find transverse pitch, transverse pitch, this is represented by P suffix T, Pt. Friends, for the boiler joint, this Pt, the transverse pitch, depends on P by D ratio. Well, I will say here, for the given joint, that is the boiler joint we are considering, for the given joint, boiler joint, comma, Pt depends on P by D. So let's see what is the ratio of P by D we have got. Here P by D, P is equal to 147 and the diameter of the rivet we have taken is, the value of D we have got already, that is 39. And this ratio works out, P by D is greater than 4. So it depends on the ratio P by D. This is P by D is lesser than 4. Yes, it is lesser than 4. When this is lesser than 4, there is a boiler code, American Society of Mechanical Engineers boiler code, that is ASME boiler code, specifies whenever this ratio is lesser than 4, you take Pt, the transverse pitch, equal to 1.75D. 1.75D. as per ASME code. As per ASME code, it says it should be 1.75D. It works out to 68.75. 68.75 millimeter. So I got the value of P, the longitudinal pitch, PT, the transverse pitch, and you will have to find out what is called margin. That's also very important parameter. M is margin. Friends, if you refer to the machine design data handbook, for any joint, for all the joint, whether it's a butt joint or a lap joint, and whatever will be the type of those joints, the value of margin is 1.5D. What is the meaning of margin? That is the minimum space between or minimum distance between the center of the extreme rivet to the nearest edge of the plate. So it is universal. It is 1.5D. And friends, it works out to 58.5. 58.5 millimeter. So for the butt joint, you have found out the diameter of the rivet and thickness of the shell. We have got what is called the longitudinal pitch, transverse pitch, margin. And finally, for this joint, you will have to find out what should be the thickness of the butt plates or butt straps or cover plates. So thickness of there are two plates, thickness H1, comma H2. So H1 is the thickness of the inner cover plate. Thickness of the inner cover plate. This is 0.625H, and H2 is the thickness of the outer cover plate, that is 0.75H. We know the value of H, and hence we will be able to calculate what is H1 and H2. This works out to 22 mm, and this H2 works out to 27 mm. So friends, with the given information, we are able to compute all the parameters required for this joint, namely the diameter of the rivet, the diameter of the hole to be drilled, the value of longitudinal pitch, the transverse pitch, margin, and thickness of the cover plates. So this is the design what we have done for the longitudinal joint. That is along this length, longitudinal joint. Friends, next we are required to design the circumferential joint. Circumferential joint. Friends, the longitudinal joint is a butt joint and the circumferential joint is a lap joint. It is a lap joint. This you should remember. Longitudinal joint is a butt joint and circumferential joint is a lap joint. And friends, in the circumferential joint, which I have shown like this here, we have to find out how many number of rivets are required which are to be equally distributed along the circumference. So the longitude lap joint, I have taken double riveted lap joint, and here friends, the size of the rivet used in circumferential joint is same as those used in the longitudinal joint. So whatever the value of D we have calculated for the lap joint holds good for the circumferential joint also. And we should know how many number of rivets are required. So to find the number of rivets for the circumferential joint, we are going to equate the bursting load caused due to the stream pressure inside, that is PF, to the resistance offered by the rivets for shearing. So here to find I, to find number of rivets, number of rivets, comma, we equate the bursting load in boiler to resistance offered by rivets for shearing. So this is very important. See, without knowing this concept, you cannot solve the problem. What is the bursting load? Friends, you got a pressure inside this shell, and pi by 4 d square, that is di square, is the area of the shell multiplied by the what is called pressure inside, area into pressure. This will be Newton per millimeter square, this is millimeter square, and finally you are going to get what is called the load, the bursting load in Newton. And what the resistance offered by the rivets. Say there are I number of rivets and each of them has got an area pi d square by 4 rivet area, and the shearing resistance is tau, shear stress is tau. So this is area of the rivet, total area, the product will give you total area into the shear stress will give you the total resistance offered by all the I rivets to withstand or to, the number of rivets required to sustain this steam load. Friends, we know the diameter of this shell, that is 2000. We know the pressure, that is 2.5 Newton per meter square. I is under question mark. Diameter of the rivet is known. Shear stress is 60. So we know all the parameters in the equation, and you can find out what is I, the total number of rivets required for the circumferential joint. And remember, the size of the rivets used for this joint are the same as that of the longitudinal joint. Friends, you get the value of this I as 109.6, 108.6. I is equal to 108.6. Say this is 110. 110 number. So it's a number. I is equal to 110. So these 110 number of rivets are distributed equally along the circumference in two lines, one here and one again here. So you can say these two equally. So number of rivets on each row, that is along the circumference, is equal to 110 divided by 2. So it will come to 55 millimeter. 55 number. There are 55 number of rivets along this, 55 here. Then friends, after finding out that, you should know how they should be placed. Friends, here you can see you have the inside diameter of the shell, that is di. The thickness is h. So the outside diameter of the shell will be di plus 2h, and over which you are going to have one more plate, that is lap plate, that will have a thickness of h and h. So di plus 2h plus 2h. That is the total outside diameter. So we can say longitudinal pitch for circumferential joint is equal to outer circumference, that is at the outer surface, circumference divided by number of rivets. So circumference will be, I told you, this is pi d is the circumference, that is pi. What is the diameter? So this is di plus 2h, di plus 2h, plus again we are going to have one more plate for the lap joint that also have say thickness h, so h plus h, divided by number of rivets on each is 55. So friend, this is going to be pi, di is 2000 mm plus 4 times h, 4 into thickness of shell is equal to h value is 35 divided by 55. You can calculate the value of the longitudinal pitch. And finally, friends, the transverse pitch, that is this pitch, PT, is given by the formula transverse pitch, PT is equal to 2D. So this PT is equal to 2D. There is gap between these 2D. 2 into diameter of the rivet is about 39. That is equal to 78 millimeter. It's a distance pitch. So friends, this is how we design a boiler joint. That is a riveted joint for a boiler. When the pressure inside the boiler and the diameter of the boiler are known, you will be able to design both the longitudinal joint and the transverse joint, that is circumferential joint. So friends, remember, in this you should always remember that the longitudinal joint is a butt joint, whereas the other circumferential joint is a lap joint. So if you just remember this, I think you will be able to get 90% of all the information from the handbook itself. Friends, once again I am advising you that this is a very important question which may be given directly, the full design, or most of the time they ask you design of the longitudinal joint only. So please go through my complete video and share the information about my video and my YouTube channel to all your friends. I thank you very much for watching my YouTube video and have a nice day. Thank you.